to get done. So let's get on it. So we're going to be doing ellipses in the conic sections. I also have a bunch of announcements, but people aren't here. Just so that you guys know, the big announcement is that June 1st, everyone is going to be taking the final with the seniors. So that is June 1st is going to be the final for everyone. So what we're going to do is later today, I'll post a review for the final. And if you guys want to get started on that, you can do that. So June 1st will be our final, okay? And I'll announce that at the end as well. Okay, so we have a lot to do with the ellipse because we're a little crammed for time. So a big point of an ellipse, so an ellipse is the sum of the sum of distances from two foci. Is always the same. Okay, so that is what an ellipse is. So if you want a visual of that, okay, so you would have a vertex, you would have foci 1, focus 2, okay. The idea is if you have a point xy on an ellipse, that D1 and D2, so D1 plus D2 equal a constant. Okay, so that's the definition of an ellipse. It's the sum of the distance from the two foci is always the same. Okay. So that's what an ellipse is. So now with an ellipse, there's going to come a lot of letters and numbers and what they're meaning. Okay, so that is kind of the definition of an ellipse. And then when we have an ellipse, there's also some other things. So now we're not going to talk about eccentricity today, but eccentricity is basically how far away it is from a circle. But we're not going to get to that. I just wanted to name drop that. So let's talk about this. So you're going to have your vertex. So that's going to be HK, right? So that's your vertex. Okay. You're going to have two focuses, or foci. So if we call this foci 2 or focus 2, focus 1. Okay. So let me kind of do this here. So this distance here is called the minor axis. And it's minor because it's smaller. Okay, so the minor means smaller. So that means that this way, right, this is your major. Okay. So, you guys with me on that? So your minor axis and your major axis. So major just means bigger. Okay. So the way that this works is, so if we go like this distance right here is B. So B equals 1/2 the major axis. And then this distance right here is A. So A is 1/2 your major. Okay, so B is 1/2 your minor axes and A is 1/2 your major. A common mistake people make is they think A is your major. It's not. So A is defined as being 1/2. The distance between the center and the focus is called C. So that's the distance between the vertex and the I should call it the center. Sorry. Okay, the distance from the center to the focus is called C. Okay. And then I think that's all the big stuff. And then also another thing to point out is if you have this, 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 and this, so all in blue, these are called the vertices. Vertices. Okay, so that is kind of your vocabulary for ellipses. You have your center. The foci are C away. Okay, so your foci are C away. Half of your minor axis is your B. Half of your major axis is A. Okay, and then the vertices all around. Okay, so there's a couple of definitions. Now there's a cool proof here. Now normally I would show you the proof of how to get the equation of an ellipse. I don't have time to do that today, so I'm really sorry. But if you guys want to see the proof, it goes from page 708 to 709 in the book. And it's a really cool just look of where this comes from. Okay. So let's take a look at this. Now, I just want to show, let's draw the second one. So let's say I have an ellipse that looks like this, right? So we'd have our center, HK, we'd have our foci. So notice how our foci are always on the major axis. Okay, I'm gonna zoom out just a little bit here. So our foci are always on our major axis. So that's a key point that we want to look at. So the foci always on the major. Okay, so if we're going up and down, then that means that our major is now up and down, right? Because major means bigger, right? So wherever the major is, wherever it's longer, that's the major, right? So this then would be the minor. Okay, the minor axis. So if we were to take a look at some things here, right? So half the major is A, half the minor is B. The distance from here to here is C, right? So from our center to the focus is C. And then the vertices, all right, are going to be along the major and minor axes, right? So these are your vertices. Okay. Now, both of these are going to have default equations. So try not to like just memorize these, but again, I'm really sorry. I wish I could just prove this to you. It's basically, remember how circles are triangles? This is basically just a circle, but the ratio isn't 1. So, and what I mean by that, and we'll talk about that. So the key thing to hear, do you guys see how the major is with the x-axis, right? Like, so just kind of say that in your head. The major is with the x-axis. Oh, so then the major is with the x. So to do this, it would be x minus h quantity squared over a. Do you see how the major is with the x-axis, and it's a squared, and then plus, and then we have y minus k quantity squared, and then the minor is with the y. Okay, and this equals 1. And again, I'm sorry guys, I don't have time today to do the derivation of this, which makes me really sad. It's actually a really fun derivation and it makes sense, but I just don't have the time today and I'm really sorry. Okay, so check out this equation. Notice how the major, right, the major axis is with the x, right, because it's going left to right. So that tells you, right, that the major is with the x and the minor is with the y. Now here, okay, you can go ahead and write these the same way. So x minus h squared, right? But then the x is with the minor. So then I would just put b squared underneath here. And it's plus, right? You see how it's plus? So order doesn't matter, right? All that matters is that you have your major and minor with the right axes. Okay? So those are your equations. Now, part of your assignment, you can already piece it together, right? It's going to be like what we did. This assignment is going to be very much like the last assignment we did, okay? But the only difference is that A, B, and C have slightly different meanings, right? So you still have H and K. That's still your center, or your, we called it a vertex, right, for the parabola, okay? But you can imagine if I give you an equation, I'm going to ask you, okay, where are the foci and where are the vertices, right? Like, you don't have to find those points, right? And that's something that you did in your last thing. So we're going to have to experience that as well. We'll practice that here in just a second. Does anybody have any questions? I really want to drive home that your major, right, is 2A and your minor is 2B, right? Just like your major is 2A and your minor is 2B. That is the single most common mistake people make, is they think the major is A. It's not. It's 2A. So A is defined as, 2B or not 2B. That is the question, right? Is it 2B or is it not 2B? Yes, you stole it right out of my mouth. All right. There is a lot of really good jokes here. I'm really sorry though, guys. I'm stuffing 2 lessons into one, so we got to get going. So if you guys have questions, you just need to ask. You just need to throw it out there, and do it. Okay. So we're going to practice doing this then. Okay. So let's take a look at my notes here. So I'm going to do. Okay. So we're going to write the equation. Now, I'm really going to warn you guys here. The book calls this standard. And I hate that it's standard. When the book is referring to standard, it's talking about the conic standard. So it's not talking about the polynomial. At the end, we'll talk about the polynomial, okay? So write the equation. We talked about that at the very beginning of conics, right? How there's the geometric way and the algebraic way of looking at conics. So when it says the standard equation, that's the geometric way of looking at it. So we're going to write the standard equation for an ellipse given. So we're going to have foci. So foci is plural of focus. Remember, if word ends in US, we replace it with I, and you can't get much more American than that. So I'm going to go 0, 1, and 4, 1. Okay, so I'm going to kind of just talk our way through this. So just like last time, drawing a picture here is going to be so important. Okay, so the first thing I'm going to do is I'm just going to go ahead and draw a picture of these. So 0, 1, okay, I'm right here. And then 4, 1, 1, 2, 3, 4, I'm going to go up 1. Okay, so I have my foci 1, focus 1, and focus 2. Okay, so now the first thing I look is see how our foci are in the x direction. Do you guys see how they're left to right? So if they're left to right, then I know that my major is going to be with my x. Okay, so that's the first thing that we need to have down. Okay, so what do I need to find? I need to find my h and my k. I need to find my a, and I need to find my b. Sound a little Canadian there, eh? So to find the vertex, remember it's COA. Okay, it's COA, and I skipped some things here. In fact, I'm going to go back. Did you okay, I do. I want to go back. Can we add one thing? I just don't have time to prove this. Can you guys add one thing to your list and just add this? So c squared equals a squared minus b squared for an ellipse. And I just really don't have time to prove this to you, but it's a really easy proof. Like really easy proof. And I can show you. Do you guys? Oh my gosh. Okay, I can't. I just don't have time. I'm really sorry, guys. I can't prove this to you. You're just gonna have to take it for value. It's in the book. I just don't have time. If I have time, I'll come back to it. Okay, so notice how it's not Pythagorean theorem. Are we super clear on this? Do you guys see how this is not Pythagorean theorem? This is not Pythagorean theorem. There's a proof for this, like I said, on page 708 and 709 in your book. I really hope you guys take a look at it. It's really easy to prove. I just don't have. Why not explain it tomorrow? Because you guys are going to be working on your assignment tomorrow. You're gonna want all the time. Okay. All right. But maybe I'll do it quietly in the background. Okay. Hey, G Flow. What? All right. So let's go back to this. So I'm gonna write down this as well. C squared equals a squared minus b squared. Okay, so this is the information that I have. Okay, oops. This is the information that I have. So what I'm gonna do here is first I'm gonna find the vertex. Okay, so first find the vertex. Gosh. Parabolas, right? First, let's find the center. Okay, same idea. So find the center. So the center is just going to be in the center here. So you find what's the halfway point between 0 and 4? So that's 2. So my center is going to be right here. So my center, right, I'm just going to do some work down here. My center is going to be at 2, 1. Okay, so that's my H and that's my K, right? It's going to be halfway in between those two. Okay, so then what that means then is that my C equals 2. Okay, my C equals 2. Okay. So then the next thing we want to do is we need to find our A and our B. Okay, to do this. Oh, I was about to say, I forgot to tell you guys. Given, sorry, and this one is the major, sorry, this is just like your homework. Your major axis is 6. Sorry about that. You needed that last piece. Make sure you guys add that in. Sorry. Okay, so you have 2 foci and your major axis is 6. So if your major axis is 6, then what's your A? Your A is going to be half of your major. So your major axis is 6, so A is going to equal 3. Okay, so A equals 3. Okay, so then now, so 2, find A, B, and C. So we have A and B. So to find B, we're going to use this equation. So we're going to say, okay, 2 squared equals 3 squared minus B squared. We're going to solve for B. Okay, so to do that, I might add B squared to both sides and subtract 2 squareds from both sides. So I'll get B squared equals 3 squared minus 2 squared. Oops, sorry. Get rid of the square root. Again, we're talking about a distance here, so only the positive is going to really matter here. So I'm going to get B equals the square root of 3 squared minus 2 squared. I can do this one in my head. 9 minus 4 is 5, so it's going to be the square root of 5. Okay, and you don't want a decimal answer. Okay, you don't want a decimal answer here. And guys, that's it. Okay, so we can go ahead and write our answer here. So our answer is, right, we're just going to plug it in. So I have x minus h quantity squared all over a squared, so that's 9, plus y minus 3 quantity squared all over b squared, that's 5. Do you guys see how we don't want a decimal answer there? If we had a decimal answer there, everything would be crazy. So what did I do? Let's recap this. I drew down my 2 foci. Okay. In the problem, it told me my major axis is 6, so that gives me my A. Once you have your center, yeah, I don't know where I got 3. There was no 3. Sorry about that. Oh, there was A was 3. I don't know. I was just looking at the 3. So I drew down my foci, right? I found my center. Okay, you can find your C from the distance from the center to one of your foci, and then it's going to give you one of the other ones, whether it's the major or the minor. Okay? So does anybody have questions? Because like I said, we have a lot to do today, and I got to get through all of it. So does anybody have questions about that? Okay, no one has questions. Okay, so I'm going to go ahead and show you a different thing. So this is going to be one part of our homework tomorrow. And that's you're going to be given some foci, some major axes, and really you could be given anything and you have to find everything. And so this is kind of your bread and butter. So it's first like, hey, am I going left to right? Am I going up or down? And going from there. Okay. All right, let's do another problem here. If I have time, I'll come back and do another one of those. Okay. I just got to make sure I get through everything. Okay, the next part is the hardest part. And I think you guys probably struggled a little bit in the homework with this because it has to do with completing the square. So we're going to go from polynomial to geometric. So we're going to take x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. So this is polynomial, and we're gonna take this and then put it into, and I hate this, standard form. It's not really standard form, it's conic form, right? Okay. So we're going to take this. So this is polynomial form, right? So this is as an algebraic representation of an ellipse, and we're going to put it into standard geometric form. Okay, so we're going to go from an algebraic form to a more standard geometric form. Okay, so this is going to take a little bit of time. So as always, guys, make sure you're asking questions, because I always lose people on this because they don't like completing the square. Because how many squares are we going to have? 2. So how many times are we going to have to complete the square? Twice. Okay, we're going to have to complete the square twice, and it gets tricky. Okay, so the first thing I'm going to do, first thing I check, see how everything is on the left? Good, right? If everything's not on the left, you want to get everything to the left. In algebra, you call this standard form. Do you guys see how standard form is really stupid? Okay, so you're going to want to get everything over to the left. Once you get everything over to the left, what you're going to, what I would do, so perfect. Actually, I'm going to take that back. I would get everything to the left that has an x and y in it, but move the constant. So this is what I mean. So I would subtract 9 from both sides. So on the left, you only have x's. Now I'm going to draw my x's as blue. And I'm going to leave a little bit of space because I know I'm going to complete the square. And then I'm going to have 4y squared minus 8y, and then leave a little space. I can put a plus here, right, because it's positive. And then equals negative 9. Okay, so this is how I would start the problem. So I have everything on the left has an x or a y in it. I grouped my x's in descending order. I grouped my y's in descending order, and I put all my constants over there. And the reason for that is we're going to make the blue, we're going to make this a perfect square, and we're going to make this a perfect square. And remember, with a perfect square, what do I mean by that, right? We're going to get it so it's just one factor squared. Okay, that's what a perfect square is. It's just the same factor twice. Okay, so now this is where things are going to get complicated. Now remember, with computing the square, we don't want a to be not 1. Oh my gosh. So this is where it's going to get real. So if a is not 1, you have to factor first. So the first thing I'm going to do is I'm just going to rewrite x squared. But with the red, do you guys see how the a term, it's 4. So I'm going to factor out. So I'm going to have 4 times the quantity of y squared minus 2y. And then I'm going to put parentheses like this, and then equals -9, right? So I factored out the 4. So if a is not 1, you factor it out. Okay, now this is going to create all sorts of headaches for us down the road, right? Because whatever I add in here, it's not actually that. It's 4 times that. Does that make sense? Do you guys see how I pulled out a 4? So whatever I add here, it's not that. It's 4 times whatever I add here. And that's going to come back later. Okay? So what I'm going to do now is I'm going to, so since I have a binomial for the x's and a binomial for the y's, I'm going to complete the square for both. So to do that, remember, a perfect square, that means the linear term is the addition of the same number, and the constant term is the multiplication of the same number. So then I just want half of that. So my b then, half of 6 is 3. So I'm going to add b squared to both sides. So 3 times 3 is 9, right? So this is my b squared, and then I'm going to add 9 over here. Okay, do you guys see how I did that? So I completed the square here, and then you have to make sure, since I added a 9 here, I'm going to add a 9 here. Okay, now I don't want to lose anybody. I'm going to do the y now. So I divide by 2. What's half of -2? Well, half of -2 is -1. So I'm going to add -1 squared. Well, -1 times -1 is 1. But be careful. When I go to add my b squared over here, I didn't add 1 to this side. I added 4 times 1. So I'm going to add 4 over here. And people are going to make crazy mistakes with that a whole bunch. Did you guys see how I added a 4 over here? Okay, and so my b squared is, it's 1, right? So it's my b squared times 4. Okay, so do you guys see how I wrote 4 times b squared here? Okay, so because my b squared is 1, but it's 4 times my b squared. So I'm just going to stop there for a second. And if you guys have questions, let me know, because this is where people are always like, whoa, I didn't get what you just did. Okay. Yeah, what happened to the 4 and the -1? Okay, so half of this is -1, right? So if we ignore that the 4, let's just look at this world right here. If I want to make this a perfect square, -1 plus -1 is -2. -1 times -1 is +1, right? So y squared minus 2y plus 1 is a perfect square. The problem is that there's a 4 here. So if I add a 1 here, if we distribute this 4, I really just added a 4 to the left side of this equation. So then I'm adding a 4 here. And that's why I wrote what I'm adding here is 4 times b squared. So b squared is 1. Yeah, and then I multiplied by 4. See, thank you. I knew someone was going to have a question. All right, so then now, once we have this, then we just put it into squared form. So we're going to have x plus 3 quantity squared, right? See how my b is 3, so it's plus 3, plus y minus 1. You see how it's a -1 quantity squared, and then there's a 4 here, right? Just want it, you guys see how the 4 is there, right? So it's 4 times this, right? And then that equals, well, negative 9 plus 9 is 0. So I'm just going to end up with 4. I'm just going to end up with 4 there. So what's the last thing I do? The last thing I do is I want to get it equal to 1. Okay, I want to get equal to 1. So how do I get it equal to 1? I divide everything by 4. So here's my final answer. You guys ready? My final answer is x plus 3 quantity squared over 4 plus y minus 1 quantity squared equals 1, because the 4's here go to 1. So that means my center is at negative 3, 1. This is my h and my k. It means that my a equals 2. My b is 1. Okay, and then you would have to solve to find your c. So, right, this is some extra math. So c squared equals a squared minus b squared. So a squared is 2, or 2 is, right, and then minus 1 squared. So 4 minus 1 is 3. So c equals the square root of 3. So then my foci is, now I'm opening, right, my big one here, my a, the bigger number, a is bigger, right? So it's going to be opening left to right. So remember, c is the distance away from the center to the foci. So if my c is root 3, then my foci is going to be negative 3 plus root 3, 1, and negative 3 minus root 3, 1. And there you have everything. Okay, so that's the whole problem. So let's talk questions. What do you guys got for questions? So again, the center, I got it from here. This is divided by a squared. So the square root of 4 is 2. This is divided by 1 squared. So that means b is 1. I use this equation to get the square root of 3. And then here's my foci. So do people have questions or comments? And I know we get out at 2, but I have another example, and then I'm going to try. Can I go over how to get the foci? Yeah. So the distance between these is c. So if we know that my center is hk, if I'm going left to right, then my foci is going to be h plus c, and this is going to be h minus c. Right? So if I'm going left to right, I just add c, or I subtract c, because that's the distance between the center and the foci. Does that help out? So yeah, so if my c is root 3, then I'm just adding root 3 or subtracting root 3. And I do that because I know, right? I know that my major is in the x direction. So I know that my foci are going to be in the x direction from my center. So that's what's going there. If we have more time, I can do one more of those, because I know, right, these are the most math intensive to do, right? But we can't also forget, right, that we also are going to have problems like this. Okay. Let's do, I have another problem, and then we'll see how much time we have left, and then maybe we'll do an extra practice problem. You can see where I didn't really have time to do the proof of the a squared, b squared, c squared thing. All right. So now let's do one more of those. So this one's going to be slightly different. So we're going to find the center, vertices, and foci of 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. Okay, so here's one more go at this, and if we have a little bit of extra time, I'll go back and practice another one of that first one. Okay. So again, if we're going to get the center, the vertice, and the foci, right, this is in polynomial form, we're going to want to get it to geometric form. So that's going to mean completing the square. Okay. So we're going to start by getting everything that has an x or y into it to one side. Okay. Again, I'm going to color coordinate this because I just really want to make sure you guys get this. So I have 4x squared minus 8x. I'm going to leave a little space, and then I have plus y squared plus 4y. I'm going to leave a little space, and then I have equals positive 8. All right, and again, stop me at any point if I'm either A, going too fast, or B, you have a question or a comment. First thing I noticed is this x, the A isn't 1. So I'm going to factor okay, and when you factor the parentheses, so important, okay, or else you're going to forget that it's really 4 times that. And then I have plus y squared plus 4y, and then equals 8. Okay, so now I'm going to complete the square on these. So I'm going to take half of 2, oops, almost wrote negative 2, so I get negative 1. Okay. B squared, negative 1 times negative 1 is positive 1. But then I have to remember what I'm really adding to this left side is 4 times 1. So I'm going to add 4 times b squared. So that is 4. Okay. And then here, I'm going to take half. Half of 4 is 2. 2 squared is 4, right? So this is b squared. So I'm going to add b squared over here, which is 4. All right, so now that I've completed the square for both of these, and the reason why we have to do all this work is kind of like, why don't you just stop when you get the b? Because, right, that's what your perfect square is going to be. Because you need to know what you're adding to this side. If you forget to add to this side, you're creating an imbalance in the equation and it's no longer equal. Okay. So what do we have here? We're going to have 4 times x minus 1 quantity squared plus y plus 2 quantity squared equals 4 plus 4 is 8. 8 plus 8 is 16. Show my work. Show your work. And then the last step, right, is I need to get this bad boy equal to 1. Feel like Puffy Combs. Bad, 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 bad boys. What you gonna do? Maybe that's I mean, it's bad singing, but maybe that's past your time. Okay, so remember, we always want to simplify. So how many times does 4 go into 16? Goes in 4 times. So my final answer is going to be x minus 1 quantity squared over 4, and then plus y plus 2 quantity squared over 16 equals 1. So the first thing that I'm going to notice here is where the major axis is, right? Is the major axis with the x or the y? And it's like, oh, 16 is bigger than 4. So y now is the major axis, right? So y is now the major axis. So let's see what we know here. So I know that my center is going to be 1, -2, right? That's my h and my k. I know that my a equals, ooh, I almost did it. So a is your major, right? It's part of your major. So this is the square root of 16, right? Square root of 16 is 4. And then your b is going to be the square root of 4, which is going to be 2. Okay. You guys doing okay so far? So I got that just from my equation. So what I'm missing is I don't have my vertices and I don't have my foci. Okay. Well, to get my foci, I need C. Okay. So I need C. So the first thing I'm going to do is I'm going to do a little side work up here. C squared equals A squared minus B squared. So I'm going to have C squared equals, well, I can just use these numbers, right? 16 minus 4. So C equals the square root of 16 minus 4 is 12. Square root of 12 isn't a nice number. Okay, so I'm just going to leave it. So then my foci, right? And this might help to draw a quick little picture. I have my center. I have my foci. So do you guys see how I have my foci up and down? So if my center is HK, then when I go to get my foci, it's going to have the same H, but it's going to have K plus C. Or it's going to have the same H, and it's going to have K minus C. Do you guys see how I'm either adding C or I am subtracting C? Okay, so, well, I know my center, right? So my foci are going to be at 1, and then it's this, so it's going to be -2 plus root 12, or it's going to be 1, -2 minus root 12. But wait, there's more. Okay, so the more is we got to find our vertices. So there's 4 vertices. Okay, so how do you find them? Well, you take your center and you add A, or you subtract A. So maybe, do I need, here, I'll draw one more. I'll draw a new triangle, or a circle, ellipse, sorry. I know what I'm talking about. So this is A. So if this is HK, this point would be HK plus A, and this would be HK minus A, and then this point here would be the same K but different H. So this would be H minus B K, and then this would be H plus B K. So does this picture make sense to you guys? And I'm not gonna lie, I have to draw a picture. People who can do this in their head, more power to you. I am not one of those people. I have to draw a picture and I have to think about it, or else it's just too much. I get overloaded, and then I go sit in a corner and I cry for a little bit until I feel better, you know? Get out that anger. I'm no Sith, you know what I mean? Okay, so let's do this. So our vertices. So I'm going to have, let's do our major vertices first. So I'm going to have the same X, but then I'm going to have the k plus a, so negative 2 plus 4, so that's 2, right? And then I'm going to have the same h, but then I'm going to have k minus a, so negative 2 minus 4, that's going to be negative 6. Okay, and then let's do the b ones. So I'm going to have h plus b, so b is 2. So 1 plus 2 is 3, and the k is going to be the same. And then I'm going to have h minus b, so 1 minus 2. So then I'm going to have negative 1, negative 2. So again, if you guys can do this without a picture, more power to you. Like I'm not going to claim that I am smarter or more brilliant than anyone in this room. I just happen to know how to do things, and I have that from years of experience. So boom, there's that. Now I do have about 8 minutes left of usable time. So do you guys have questions about this, or do I have time to go back and take a look at another of the first example? And guys, like, there's no formula for this. There's no right. I mean, it's just like you just got to think about it. This is you're starting to enter the realm of mathematics where being clever is a skill, right? And like you just have to like really just grind it out. You just got to like sit down and be like problem solve, right? Like we're getting into real math, real problem solving, where you have to like create a little picture, problem solve, tinker with it, and then get everything. Okay, so there's no like process. Every problem's a little bit different. Okay, which is fun. I think this is the kind of math that I think is real math. I feel like the math we do in algebra is very boring. It's very formulaic. It's like why can't a robot just do this? Well, a robot can do this too, so that kind of ruins that. All right, questions here? Let's go back and do one more like that first example, and I'm going to do that with the little amount of time that I have. Okay, so this is going back and taking a look at a different example. So so let's say given foci of negative 2, 2 and 4, 2, and also given that the minor axis has length. I made this way too hard on myself, guys. Sorry, I have to do a little bit of math. I tried to switch up this problem. Eight. Okay, I want you to write the equation. So give that a try. So we can only do about 2 minutes. So take 2 minutes and then we'll go over this. And I would start by graphing the foci and seeing, okay, are the foci along the y or the x-axis? Figure out what equation you have and then go from there, right? You can find your center, you can find your c. All right, I would check YouTube to make sure you got your solution correct if you're going to leave early. All right, so really quickly, what I would do is I would plot these 2 points. So -2, 2, and 4, 2. So that tells me the major is along the x-axis. So I'm going to have something like this. Okay. And then, so I have to find halfway point between -2 and 4. So that should be 1, 2. So my center is at 1, 2. Okay, which means my C is 3. And my minor axis is 8. So B will equal 4. It's going to equal half of that. Okay, so then I also know C squared equals A squared minus B squared. So if I go C squared plus B squared, that equals A squared. So I have 3 squared plus 4 squared equals A squared, or the square root of 3 squared plus 4 squared equals A. 3 squared is 9, 4 squared is 16, so that's 25. So C is 5. A is 5. So then to write the equation out, I'm going to have x minus 1 quantity squared over a squared, which is 25, plus y minus 2 quantity squared over b squared, which is 16, equals 1. Okay, and if you guys have questions, please go ahead and ask. Does anybody have questions on how I did this? We have a couple of minutes that you guys can ask questions. How did I find the vertices of the last problem? So you just have to remember A and B are defined as being from, A and B is defined as being the distance from the center to the vertices. So if I go back and show you this picture, right? So B is defined as being the distance from the center to the vertices, and A is defined as being the distance from the center to the vertices. So so to do that, I just drew a picture and be like, okay, I have my center, it's HK, right? So then to go up, I'm adding A to my Y because it was up and down, right? So you just have, so first you have to know, is your A left to right or up down, right? So if your A is up and down, then you're going to be adding A to your Y. If A was left to right, right, we'd be adding A to the Y in the, we'd be adding A to the X term, right? So that's why I draw a picture. I say, where's my A, where's my B? And then I really just think about like, hey, am I adding it, if I'm going left to right, I'm adding it to my, whatever the X is. And if I'm going up and down, I'm adding it to whatever my Y is. Okay. And if you have more questions, then I'd also say, guys, you're always welcome to come to my office hours and ask more questions. And then tomorrow we're going to practice these problems, okay? But yeah, I just drew a picture. And it was just like, hey, if A is going up and down, then I'm going to be adding A to my Y. And if B is going left to right, I'm adding it to my X.